So where do you get the best scientific data for figuring out how to optimize the performance of a boat tail? Because there's a lot of discussion about that, and maybe not everybody quite understands that.
Okay, so it's a hard thing to really, accept, what a boat tailing effect will do, and there's a lot of numbers thrown around, and it's hard to really trust anything actually if you don't really know where this comes from. And I mean, in natural forms of birds and aquatic animals, they have a sort of a streamlined form for a reason: energy conservation. So it's really just a transition of that.
Biomimicry.
Yeah, I suppose it is biomimicry. Good, Gail. That's a good word. Okay, so we are kind of copying what natural forms do to conserve energy. So how do you know how much it does for sure without any, snake oil aspect to it? And that is really the wind tunnel. The wind tunnel tells you very precisely what the drag reduction is in a wind average scenario, not just one windy day we took it out and we got this. That doesn't mean anything really. It means something, but it's not useful. You want to know what the long haul average is, given wind data from North America or Europe or anywhere. What is the average wind, and what exactly would be the average yaw, or let's say the collective effect of all the different wind scenarios that occur? And what is the number in terms of drag reduction in that scenario, the average? So that number is a very piece of good, it's hard science, and that's how we know. That's how we've studied this, and it's well established.
So which wind tunnel did you go to?
We went to the NRC wind tunnel, the National Research Council of Canada wind tunnel in Ottawa, to do our wind tunnel tests.
And then you went to another location for a different type of testing, the smart way.
Yes, so we then took a prototype to the Transportation Research Center in East Liberty, Ohio, which is a big, beautiful oval test track, and ran some fuel data on that, and it's remarkably consistent with the wind tunnel. It's like extremely consistent. The thing about the retract is that the wind is highly variable. So you have to consider what the wind was that day on that test and see if it matches what the wind tunnel says for that particular degree of wind, or like average yaw. It's called the angle at which the wind attacks the trailer. So those two things line up very precisely. It's the track and the wind tunnel say the same thing very closely.
And when you ran the test track testing, there were two vehicles, two tractor trailers. And do you want to explain why that was?
Well, if you have, this has to be done, they're very good there. That test center they were excellent. The methodology. You have to run two trucks at the same time on the same road, and they weigh the fuel before and after, and it's extremely precise. If the control truck is not run at the same exact time on the same road, then it's pretty much, you can very distorted numbers. You can really, if the control truck is running slightly higher wind than the test truck, then your performance number looks way more than it actually should, than it actually is. So that's these kind of things can be not noticed, when you're looking at data on performance data for this kind of device. So there are standards and there are methods, and if you follow them, there's no uncertainty, there's no mystery. It's that's what it is. As long as you're driving at 60 miles an hour and you're on the highway and the wind is the wind data on average is known, then the outcome is predictable.